this video, we are going to discuss graphing linear inequalities in two variables. And so when we graph it, we're going to see graphically all of the solutions to our linear inequality in two variables. So this should look familiar, somewhat maybe. Think about the equation that I would have if I had an equation rather than an inequality. So in this equation, you would see that this is a linear equation in two variables. And if you remember y equals mx plus b form, slope-intercept form, this is the slope, the 1/2, and the y-intercept is given by the 2. So the y-intercept is 0, 2, and the slope is 1/2. And so if I were going to graph that line, I would use the y-intercept first. So let's go ahead and do that. I would use the y-intercept first, so 2. And then I would use the slope to count to find another point on the line. So it's rise, up 1, run over 2. So that would be another point. Up 1 over 2, up 1 over 2. And I could also go down 1, left 2, because 2 negatives make a positive. So all of those points would lie on my line. If it was an equation, I would simply connect all those dots and put arrows, and then that would be my answer, right? That would be it if it was an equation. But for an inequality, all of my answers are going to either lie above or below that line. So for an inequality, this is actually the boundary that separates the plane into solutions versus non-solutions. So this is just the boundary. Then what we're going to do is think about using the paint bucket. You're going to paint everything either above or below that line. Now, a couple of things to keep in mind. If you have a less than or a greater than, no or equal to sign, you're going to use a dotted line. So in this case, since I have a less than, I want my line to have breaks in it. So it's a dotted line. That means the boundary line, the points on the boundary line are not included in my answers or my solution set. Since it's a less than, that means everything, so this is a less than, y is less than that line. Everything below that line will be a solution. So I'm going to shade below because that's a less than symbol. Now I can only do that if I'm comparing to y. So if you do not have your equation solved for y, if it's not y on the left compared to something on the right, you cannot use that general rule of shading below because it's a less than symbol, okay? So that's our solution right there. You graph the line, you decide if that boundary line should be solid or dotted based on the symbol, and then you decide if you should shade above or below based on the symbol, provided you've solved for y. Okay, so a couple of notes to make. So a less than or greater than will have a dotted line. And again, that's because the answers or the ordered pairs on the actual line will not be solutions to the inequality. Less than or equal to or greater than or equal to, so again, notice the equal to sign, that's the key, will have a solid line. So in that case, the ordered pairs on the number line itself will be included in the solution set. So you're looking to see which inequality symbol you have. Do you have a strict inequality with no or equal to sign? Because if so, your boundary line will be dotted. Do you have an inequality with a greater than or equal to? So do you have the or equal to on it? If you do, then in that case, you'll have a solid line. And then the next thing you want to look at is how you're going to shade. So if you isolate y on the left, which I highly recommend that you do, because then the shading is much easier to figure out. Then a less than or equal to, you shade below, because it means y is less than the stuff on the right. If you have a greater than or equal to, you're going to shade above, and I mean above or below the line that you drew. So you drew a boundary line, that was the step in green, and then you shade above or below that line based on if you have a less than symbol or a greater than symbol. And this works every time. There are other ways to do this, so feel free to use another method. I think this is the easiest one that works for me, so this is how I will explain it. But if you don't like this method, feel free to look online. There are probably other videos showing you different ways to do it by plugging in points. Okay, so to use my method, the first thing I do is get the y by itself. So that's my goal. So I'm going to subtract off 4x from both sides. So that's going to leave me negative 2y is less than or equal to negative 4x plus 8. Again, I'm still trying to get the y by itself, so I'm going to divide everything by negative 2. So that's going to be y. Remember, if you divide by a negative, you flip your inequality symbol. So now it's going to be greater than or equal to negative 4x divided by negative 2 is positive 2x. And then 8 divided by negative 2 is negative 4. So I've now gotten my my y isolated on the left-hand side. So since my y is by itself on the left-hand side, I can now decide how I'm going to shade, and I can decide if my boundary line is going to be solid or dotted. All right, so let's walk through that. So my boundary line, I'm going to graph this as if it was an equation. So the slope is 2. And if you want to think of it as 2 over 1, that's fine, because that means you're going to go up 2 and right 1. And then the y-intercept is going to be 0, negative 4. So it crosses the y-axis at negative 4. And then I can go up 2 over 1 and keep doing that. Or I could go down to left 1. All those dots should lie on the line. And now I want to decide if the line is going to be solid or dotted. So because of the or equal to, I'm going to have a solid line. So because it had the or equal to, it's a solid line. Now, all I have to do is figure out if I shade above that line or below that line. It's a greater than symbol. It's greater than or equal to. That means I'm going to shade above the line. So go to any point on the line and go up. Above the line, remember it's above or below. You're going up or down. So above the line would be everything in this region. So everything above that line is shaded and would be included in your solution set. Now, if you wanted to check to see if this is true, you can pick any ordered pair that lies above this line, and you should get a true statement. Likewise, if you picked any ordered pair below the line, you should plug them in and get a false statement. So this is done. So this problem is done. I have shown my graph. Everything shaded in blue is included in my solution set. But let's kind of take a side trip over here, because sometimes in your homework it'll ask you certain things. Let's say I pick this point that I just did in green, and maybe it's hard to see the green. Let's pick it in black. Let's say I pick this random point. The ordered pair for this point is 1, 2. Let's say I want to decide if 1, 2 is a solution or not. Okay, so my question is 1, 2 a solution? The way you figure that out is you just plug it in. So 4x minus 2y is less than or equal to 8. You're simply going to plug in the 1 for the x because it's in the x place, and the 2 for the y because it's in the y place, and then see if the statement is true or not. So 4 times 1 is 4, 2 times 2 is 4, 4 minus 4 is 0. So is 0 less than or equal to 8? Yes, it is. That's true. So 1, 2 is a solution to that inequality. And any point that you pick that's in the shaded region will work. Any point that you pick in the non-shaded region will not work. It will not make a true statement. So I could do the same thing. Let's pick a different point. Let's say now I pick the point, I don't know, down here. Let's say I want to pick this point. This would be associated with 5, negative 2. All right, so let's say I want to know, is 5, negative 2 a solution? I'm going to plug that in. So 4 times 5 minus 2 times negative 2 is less than or equal to 8. So 4 times 5 is 20. Negative 2 times negative 2 is positive 4. So I'm going to have 20 plus 4, which is 24. So I'm left with this, 24 is less than or equal to 28. Well, that's clearly false, right? So that means 5, negative 2 is not a solution to the inequality given, which is how it should be, right? Again, any ordered pair that you pick in the shaded region should work. Any ordered pair that you pick in the non-shaded region should not work. All right, let's look at another one. Number 3, this is our special case. If you remember from graphing linear equations, then you would remember that this is a special case. If I had an equation, it would just be y equals negative 3. And that is associated with a horizontal line that passes through the y-axis at negative 3. And so that's how I see these special cases. I think of it like through, and I know that's not how you actually spell through, but through the y-axis at negative 3. So I'm going to go to the y-axis and I'm going to find negative 3. Here it is. And if it's going to go through that axis, it's got to be a horizontal line. And so that would be the line associated with the equation. But since I have an inequality, I have to make sure, number 1, is my line going to be dotted or solid? Since I have the or equal to sign, it's going to be solid. So I'm good where I am. And then I have to decide how I'm going to shade. So since it's less than, I need to shade below the line. So everything below that line will be part of my solution set. Okay? And that's it. Let's look at number 4. So this one is another special case. Notice that we only have an x this time. So this tells us that our boundary line is going to go through the x-axis at 5. So I'm going to go to the x-axis and find the 5, and then I would draw my vertical line. That is my boundary line. Now I want to make sure I should have a solid line. There's no or equal to. This is a strict inequality. That means that my line should be dotted. So I need to go back and make sure that I have a dotted line. Okay? So dotted line. All right. Then I need to decide how to shade. In any other case, you're comparing to y. So you're going to shade above or below the line. But in this case, you don't have a y to compare it to. You are only comparing to x. So you're going to be looking at left or right. This says x is greater than 5. The numbers that are greater are to the right. So greater than will be associated with shading to the right. Okay, because those numbers, as you go on the number line from left to right, the numbers are getting bigger as you move to the right. If you have the x isolated and it's a less than, then you would shade to the left.